This is the question number 33 of GATE 2014 Metallurgical Engineering. The question is, what is the theoretical requirement of air in meter cube at STP for the complete combustion of 100 meter cube at STP of a fuel consisting of pure methane? Assume that air contains 21 volume% of oxygen. So now let us solve these questions. So in these questions we have to calculate what is the amount of air or volume of the air requires in order to burn pure methane, 100 meter cube of pure methane. So now let us write the reactions. So pure methane CH4 is burning because of the oxygen which is coming from the air, and for the complete combustion of methane it will form CO2 plus H2O. Now if we do the mole balance, so 2 here, 2 mole of oxygen, 4 mole of oxygen, so 2 is here, so we have to multiply here by 2. So now the equation is balanced. So from this equation we can see that if we burn 1 mole of methane, it requires 2 mole of oxygen. So now it is also mentioned at STP any gas has a volume of 22,400 meter cube. So that means 1 mole of methane or 22,400 meter cube methanes requires 2 into 22,400 meter cube of oxygen for the complete combustions. But here it is mentioned 100 meter cube of methane is there. So 100 meter cube of methane will require 2 into 22,400 divided by 22,400 into 100. So it will be 200 meter cube of oxygen. So 100 meter cube of methane will require 200 meter cube of oxygen for the complete combustions of methane. So now this oxygen is coming from the air. So this oxygen, air is basically giving the supply of this oxygen, and it is also given that 21 volume%, air contains 21 volume% of oxygen. So now we have to calculate how much air is required. Let us assume x meter cube of air is required. So from this x meter cube of air we are getting 200 meter cube of oxygens. So that means x into 21 by 100 is equal to 200 meter cube. So now if we calculate, we will get x is equal to 200 into 100 divided by 21, and this will be 952.38 meter cube. So the theoretical requirement of the air is 952.38 meter cube.